For joining us this morning, folks. So today, Rob and I are going to talk about how do you manage configuration, policies, and resources at scale. My name is Sandeep Parikh. I'm an Anthos advocate for Google Cloud.
And I'm Rob Leidle. I'm a software engineer for Google Cloud.
All right, so let's start with configuration. So if you take a step back and you sort of look at the high-level view of the Anthos stack, right? You start at the bottom, you start with Kubernetes, and then you layer in service mesh on top of that. And then we've got a layer for policy controls, which we'll get to shortly. And then you've got your applications and services. And then on the left side of the diagram, we sort of talk about how you get configuration or applications, how you get software into that environment, right? Those two things. And this is the typical sort of approach we're trying to guide customers around as they think about how to set up, deploy, and operate an Anthos environment. So to start, we're going to focus on config management. How do you get the objects and resources configured in your deployment? And how do you deliver that configuration? So typically, what we still see on a pretty regular basis is that a lot of teams are still using CoopCTL to apply changes to their environments, right? They're still doing very imperative operations. And this is really challenging because as these clusters grow, right, not only in number, but in scale and size, right, we see a lot of large-scale multi-tenant deployments. It can become challenging for operator teams to sort of continue to use CoopCTL or imperative approaches because Kubernetes itself is a declarative system, right? You declare what you want the state of the cluster to be, and you push that configuration. But that doesn't really match up to imperative operations. So how do you transition that sort of imperative approach to one that fits the Kubernetes model better, that's more declarative in nature? And the first step is we take out that imperative approach, and we replace it with a sort of central repository, right, where you store that configuration information. So we start with Git, like a Git repo, which is something almost every technical practitioner is familiar with. We start with Git, and inside of that Git repo, we store all of the configuration about your cluster, right? How you configure your namespaces, any additional metadata, labels, annotations, pods, services, secrets, volumes, you name it. If it's a Kubernetes object, it can fit in that config repo. And what we're doing with that is we're trying to create this sort of approach where the state of the cluster is what exactly matches the state of your repository. So if it's not in the Git repo, it's not reflected in your cluster as well. Once you adopt that approach, right, that state that you're trying to declare become that configuration, it's effectively data, and we store it just like we store code. And because we're using something that's like Git, it becomes a process that you can use sort of typical software development workflows to kind of manage your configuration, manage your environments. So the process of deploying a new config in production follows the same software development process that you're already familiar with, right? If a team needs to create a new configuration, they can branch the repository, they can make their changes, they can validate them locally, and then they can have them merged back in, and then those changes get pushed out to production. And as I mentioned, at any given time, we want to make sure the state of your deployments matches exactly what's specified in that Git repo. And so that's where Anthos Config Management comes in. So with ACM, what we're trying to give you is the ability to define the state of your deployment and store that in a central, secure Git repository. The benefits of doing that are the same benefits that apply to typical software development, right? We have the ability to audit changes a lot more cleanly now. Instead of digging through Kubernetes logs and events and trying to figure out who made a change and what change they introduced that might have broken your infrastructure, we can just trace that back to a set of Git commits and who authored the commit, and maybe even who merged it in. You can revert your deployment and roll things back a lot easier, right, just by making a change in your Git config, right? You may revert a commit, and now production can pick up that revert that you needed to do. ACM also is self-healing. So it watches the cluster for drift from the configuration. So if by chance someone goes and applies an imperative operation and changes a namespace configuration outside of the normal workflow, the mechanism built into ACM will actually sync that change back and put it back to the state that's, again, reflected in the repository. So at any given time, again, the state of your cluster and the state of your deployment matches exactly what's in source control. And ultimately, the best part of this is that you can version your deployments just like you version software. So you can tag them, mark them as release candidates, et cetera, just like you would any of your applications. So it's a pretty powerful sort of thought process to work through. Now, the way Anthos Config Management, or ACM, works in your environment from an architectural perspective, and you can see sort of in the middle of the diagram, there's the interconnect, right? That's bridging your on-prem environment and your cloud environment. And this would be true for a multi-cloud scenario as well. But what's happening here is that you've got the interconnect, bridging the networking between the two, and then in each Kubernetes environment, or each GKE environment, there's a config management controller that we deploy as an operator. And that controller is what's keeping things in sync with the repo. And the best part is that repo does not have to live on cloud. That can live in your on-prem infrastructure. So if you want to make sure if there are particular security or compliance or guidelines around where your configuration lives, right, where the definition of that lives, you can always keep that on-prem and then have the config just sort of spread out across all of your GKE clusters. All right, so that's a little bit about how we manage configuration at scale, right? And let me go back for a quick second here. So the way you kind of configure ACM is you effectively, when you deploy the software inside of your Kubernetes environment, all you really have to tell it is where does that Git repo live, right? What is the branch or the tag you want to use for your releases, and any sort of authentication information it needs to access that Git repo. And once you've done that, it's up and running, and now your clusters are sort of under that managed state that ACM provides. So that's the config management piece. Now, how do we use config management to implement policy controls? So the sort of act of creating policies and enforcing them is something we often call policy management. Think of policies and policy management as effectively saying, I have a set of rules, right, a set of governance I want to apply to all of my environments, to all of my deployment, and I want to enforce those rules in certain ways. Either I want to not allow objects that break those rules, or I want to allow objects that might violate those rules, but I want to be able to audit them and audit any of those violations on an ongoing basis. Now, policy management and config management, there's a little bit of overlap, and I think from a mental model perspective, there's sometimes a little bit of kind of collapsing these two together, but they are very distinct, especially in the way that ACM sees them. So from a config management perspective, the config management is really all about how do you store, control, and govern, right, your deployment configuration. There's typically a process for how it gets done. In the case of ACM, that's like a GitOps style process. And there's typically a process for who can do it using something like Kubernetes role-based access control, or RBAC, to control that. But ultimately, config management's really about how you enforce object or resource state in the cluster. On the other hand, policy management is about rules, right? It's about setting guardrails and applying governance, and it's really more about, can you make a change to a given object, right? Is that change allowed? And how do we want to enforce those changes, right? Do we want to, again, deny them entirely, or allow those changes to happen and then audit them for kind of ongoing violations? A lot of times, I think the policy management angle can actually sound quite a bit like Kubernetes RBAC in many ways. But again, if you think about it, RBAC is about who can make a change and who has the power to make a change, whereas the policy aspect is really about, is that change even allowed? So it's a little bit of a higher level view of the problem. Now, I mentioned guardrails and governance. Kubernetes is an incredibly powerful distributed system, right? And powerful systems like that typically need some kind of control because you want to watch out for potential problem spots, right? You want to make sure you haven't given a particular set of users too many privileges, right? You don't want to give them too much power to make changes. You want to make sure that services are locked down and that they can only be accessed by other services you deem appropriate or by certain parties you deem appropriate. And obviously you want to watch out for things like exfiltration. You don't want data leaving your environments in an unintended fashion. But on the other hand, those controls that you want to use, that governance needs to be agile and flexible, right? You want to be able to scope that governance and that control very narrowly to only the objects you really care about. And you want those policies and those controls to be written by the people who know the compliance, the regulatory work, your organization's policies best. So So you got to make it easy to develop and deploy them. Because at the end of the day, what we're trying to get to is safe deployments. We don't want anything in production that could violate any of the rules we need to worry about on a regular basis. So as part of ACM, we have another component wrapped in there called ACM Policy Controller. Policy Controller is based on a project from Open Policy Agent and Gatekeeper. Right? Gatekeeper is sort of an offshoot of Open Policy Agent. And Open Policy Agent is really just a general purpose policy engine. Right? You write a policy, you hand it some data, it makes a decision based on those two things. Does that data violate the policy or does it not violate the policy? And what Gatekeeper and by extension ACM Policy Controller do is it takes that policy engine and it makes it a sort of first-class citizen in a Kubernetes environment, and it makes it into an admission controller. So now that means the policy mechanism is sort of right alongside the ability to admit objects to the cluster. So now you can apply rules upon admission, and so something that could potentially violate the rules that your organization has won't get admitted to the cluster. Or again, you could say things like, well, I want to allow this to happen, but I want to audit anyone who's potentially out of compliance. Right? It has that sort of capability. But because it integrates, again, as a first-class citizen with Kubernetes and with GKE by extension, all of the standard Kubernetes tooling you're used to it fits right alongside with it. It can be used alongside with it. So let's talk about a policy in depth and what the structure looks like. So there's two parts to a policy, right? There is the sort of rule definition, which is written in a language called Rego, which is part of the OPA package, the Open Policy Agent package. And then there's the actual packaging of that rule and giving it to Kubernetes. And so that packaging is called a constraint template. And it's a parameterized piece, right? You can apply arguments, you can scope it down, but ultimately the policy approach is built into two components. One is the rule definition, and the second part is how that rule gets enforced. So the constraint template here that you see is the rule definition. What are we trying to enforce? What are we trying to evaluate? How many of you are familiar with Istio in the room? All right, a handful. So you'll hear more about Istio later today, but one of the most powerful aspects of Istio is that you can automatically enable things like MTLS, right, to mutually authenticate services and clients in your cluster. But one of your organization's policies could be, hey, we want to make sure that every service that gets deployed, every client in our environment must support mutual TLS. And you want to also make sure that no one turns that off, right? You don't want anyone to bypass that, because that could be possible. Someone who has the appropriate RBAC permissions could say, well, my service is special, I want to turn off MTLS because we don't want to support it today. So what this rule is actually doing is it's evaluating part of that process and saying, hey, if you try to turn off MTLS, I'm going to catch that, and that's going to throw a violation. So this is the rule that catches that. And then the enforcement half is packaged in something called a constraint. And let me jump back a quick second. But what we're doing in this policy, in this constraint template, is if you look at that kind field about a third of the way down, we're actually defining a new custom resource for Kubernetes. So we're saying, hey, there is now a new resource called destination rule TLS enabled that lives in the Kubernetes environment. And if you actually run CoopCTL get CRDs, you'll see that in the list. So what the constraint does is it actually takes that CR and it creates another spec based around that, and it lets us scope the enforcement. And so there's two parts of this that are really important. One is enforcement action, about a third of the way down. Right? In this example, I've set this constraint to be deny. So if anybody tries to submit a destination rule that deactivates MTLS, that thing will get denied admission to the cluster entirely. It won't even get in. And the second part of it is about halfway down, where I'm actually scoping that to a particular API object and to a particular namespace. So I'm saying only scope this rule to destination rule objects that are part of the Istio API, and only look for them in the default namespace. Now the nice thing is with ACM Policy Controller, you can actually adjust that scoping a little bit, and you can say, I want to have it apply to any namespace that has the following labels or that doesn't have the following labels. So you can actually control the enforcement and application of that constraint as well. And so now what would happen if we were to push that constraint template and that corresponding constraint is if I try to push this new destination rule that disables MTLS, GKE will accept the object, the admission controller will then review it, and then decide and see that it violates the rule we've laid out, and then just kick it right back and say, sorry, we can't take it, right? And you can supply your own custom error messages and things like that, but it'll automatically just push that object back out and say, I can't accept this in, because again, it violates a rule. So now there are three sort of stages to the policy development process, right? There's obviously the authoring step, which is where you're sort of going to validate the rules in your approach. And then there's the application of it, where you may want to just firmly deny anything that is out of compliance or that violates your rules. Or there's a third step where you can say, we want to allow objects in that may potentially have violations, and we just want to audit them, right? And there are things where you may want to audit controls for maybe labels or annotations, but for something that's violating, again, regulatory compliance or any kind of corporate IT policy, those may be objects where you want to deny admission entirely, right? Again, we want to watch out for things like data exfiltration or overexposed services. So some of the example policy use cases, and by the way, I should mention, there's actually a whole bunch that are already included with ACM Policy Controller, things like checking for required labels or particular annotations or particular structure. You can do things with policies like make sure that resource constraints are baked in, right? You could say, hey, no pods and services can be deployed in this cluster unless they actually call out how much CPU and RAM they need, right? So that we can make sure that we're not overdoing the amount of resources we're going to consume for a given pod or service. But particularly around sort of security concerns, we can watch out for things like only allowing access from certain domains within your organization, right? So a service within a particular domain can access another one, but one outside of that list of domains may not be able to access services, right? Like in the example I showed earlier, we can require strict MTLS across the board and make sure that stays enforced so that no one can turn off that authentication piece. You may want to implement controls like service A can talk to service B, but service A definitely cannot talk to service C, and make that a policy. So again, if anyone tries to bypass that or override it, they will actually get booted. That configuration won't be allowed into their cluster. And there are many other examples. These are just a few, and we're happy to kind of answer questions around them as we have time to afterwards. So with that, I'm going to hand it off to Rob to talk about managing platform resources.
Yeah, so thanks, Sandeep. Bringing this together, how could you apply the same techniques Sandeep talked about to your cloud infrastructure? That's not possible today. You're going to have some sort of split-brain approach. You're going to have your Kubernetes applications managed through your Kubernetes toolchain, and then you're going to have your cloud resources managed through some other mechanism, be it gcloud or deployment manager, etc. We have now made available a new product, GCP Config Connector, and this allows you to manage your cloud infrastructure in a Kubernetes native way. And since it is Kubernetes native, integrations like Anthos Config Management just work with it. So the idea here is that you can use CoopCTL, config management, or API clients. I guess CoopCTL is an API client. But API clients like your CI/CD pipeline, and they can push configuration to the Kubernetes API server, and then GCP Config Connector will take that declared configuration, your intended state, and it'll make it a reality in GCP. So Config Connector, like I said, is Kubernetes native. The actual configuration is the KRM you come to expect from Kubernetes. You can use the K8's APIs or CoopCTL to manipulate it. It allows you to declare your intended state with declarative configuration, so you avoid a lot of the issues that come from imperative workflows. It is eventually consistent, so you can apply your configuration in any order you want, and it will eventually reach the state you intend. That also means it'll be quicker and more performant. It's idempotent. You can apply the same configuration over and over again, and you'll see no change. And it combats drift. So you can ensure that changes made by operators outside of your application's CI/CD push flow are reverted back, so you don't end up in a state where there are changes that are not in your repository. It's available through Anthos as a G-Key add-on or manual installation. And it's in beta now and going GA in Q1. So here's a little talk about the actual KRM. On the right, we have two examples. We have a pub/sub topic, which pub/sub is a popular GCP service, and a topic is a resource within pub/sub. And then we have a pub/sub subscription. A subscription is associated with a topic. That's just the way subscriptions work. And in this example, you can see in the subscriptions spec, we have a field called topic ref. And in topic ref, we say the name is my topic. And that's saying this subscription is associated with that topic. And that's just an example of how this is written, how these configurations work in the way you would expect a Kubernetes resource to work. And in terms of what resources are supported, we support resources from all the services listed there, notably compute, spanner, storage, and resource coverage is expanding. So putting it all together, you can use your Anthos configuration and policy management to manage your GCP infrastructure as well. So you can bring all those techniques to GCP. In addition, you can standardize your tool chain on Kubernetes tool chains, or Kubernetes tools, which will simplify your environment for your developers and make them more productive. So that'll give you back more of your most limited resource, which is developer time, and they'll have more time to work on your applications and things that matter to your business. And that's it for policy and configuration management. Sandeep and I and other Googlers are available to answer any questions as needed. Thank you.
Should we go to the